thank you for visiting my YouTube channel. I know you want to watch the video. Before I get into the content, I'm going to talk about my nonprofit, the Accelerated Training Program, a cybersecurity and digital literacy nonprofit based in Charlotte, North Carolina. We are looking to provide accessible cybersecurity education and digital literacy skills to underrepresented groups from the K through 12 space right now, but we have on our roadmap collegiate, elderly populations, etc. Pretty much anyone from an underrepresented group. We want them to get cybersecurity education and digital literacy skills to bring them into the ever increasing digital world that we live in now. If that sounds like something that you're interested in, we do have a donate button if you would like to donate monetarily. We're always accepting donations. If you would like to volunteer your time, we have a volunteer tab where we're looking for workshop volunteers. Currently, we have 1 month workshops, but we're looking to expand that in 2024. Board members, advisory board members, and a grant writer. So if you're a grant writer, if you have experience in grant writing and also winning grants, we would definitely love to have you on our team. To be considered, please complete the volunteer form here, which is a link that will navigate you to a Google form. And again, we're a cybersecurity, digital literacy nonprofit, and we would love to work with you if that is your passion as well. Thank you. Have a good day. And now the video is going to start. Hello, and welcome to day 15 of Advent of Cyber. This is machine learning, Jingle Bell spam, machine learning saves the day. So let me start the machine. Okay, I'm gonna scroll. And again, as I said before, I'm doing these rooms out of order, so bear with me. Okay, let's go. Okay. Over the past few weeks, Best Festival company employees have been receiving an excessive number of spam emails. These emails are trying to lure users into the trap of clicking on links and providing credentials. Spam emails are somehow ending up in the mailing box. It looks like the spam detector in place since before the merger has been disabled, damaged deliberately. Suspicion is on McGreedy, who is not so happy with the merger. Okay, McSkitty has been tasked with building a spam email detector using machine language. She has been provided with a sample data set collected from different sources to train the machine learning model. So, the learning objectives: different steps in a generic machine learning pipeline, machine learning classification and training models, how to split the data set into training and testing data, how to prepare the machine language model, and how to evaluate the model's effectiveness. So for this video, we're going to need the VM and a split screen because we see that here. Okay. So um, it says after waiting 3 to 5 minutes, Jupyter will open. Okay. So let's look at the overview of Jupyter Notebooks. Jupyter Notebooks provide an environment where you can write and execute code in real time, making it ideal for data analysis, machine learning, and scientific research. In this room, we will perform the practical on the Jupyter Notebook. Okay. It's important to note, to recall that we will need to run the code from the cells using the run button or by pressing the shortcut Shift plus Enter. Each step is explained on the Jupyter Notebook. For better understanding, let's dive into the details. So, exploring machine learning pipeline. A machine learning pipeline refers to the series of steps involved in building and deploying a machine language model. These steps ensure that data flows efficiently from its raw form to predictions and insights. A typical pipeline would include collecting data from different sources in different forms, pre-processing it, and performing feature extraction from the data, splitting the data into testing and training data, and then applying machine learning models and predictions. So we have ingestion, cleaning, pre-processing, modeling, and deployment. So I think one of the questions is, what is the first step in the machine learning pipeline? I see ingestion. Did I miss it? Mhm. Okay. I see ingestion, but let's keep going. Uh, Let me see. I'm gonna say data collection. Yep. Okay. And that was here. Okay. So step 0, importing the required libraries. Before starting with data collection, we will import the required libraries. Jupyter Notebook comes with all the libraries we need for machine learning. Here, we are importing two key libraries, NumPy and Pandas. These libraries are already explained in detail in the previous task. So we said import NumPy as NP, import Pandas as PD. Let's start our spam email detection in the following steps. Data collection is the process of gathering raw data from various sources to be used for machine learning. This data can originate from numerous sources such as databases, text files, APIs, online repositories, sensors, surveys, web scraping, and many others. So we see it started. Jupyter Notebook has started. Here we are using the Pandas library to load the data collected from various sources in the CSV format. The data contains spam and ham, not spam emails. I see what you did there. That was cute. So we have a data variable and we're reading the CSV and we're providing the file name, emails, dataset.csv. Test check dataset. Let's review the dataset we just imported. The category column contains the email classification, and the message column contains the email body as shown below. So, okay. Okay. So this is the expected output. Classification, spam, congratulations, you won the free ticket. Ham, call me back when you get this message. And remember, hams are not spam. Data frames provide a structured and tabular representation of data that's intuitive and easy to read. Using the command below, let's use the pandas library to convert the data into a frame. It will make the data easy to analyze and manipulate. So we are calling the data frame function from the panda class, and we're passing in the data, and then we're printing it. So the expected output is the ID, spam, and then the message. Okay. Data pre-processing. Data pre-processing refers to the techniques used to convert raw data into a clean, organized, understandable, and structured format suitable for machine learning. Given that raw data is often messy, inconsistent, and incomplete, pre-processing is an essential step to ensure that the data feeding into the ML models is relevant and of high quality. Here are some common techniques used in data pre-processing. Okay, cleaning. Correct errors, fill missing values, smooth noise, and handle outliers to ensure the quality and consistency of the data. Normalization, scaling numeric data into a uniform range, typically 0 to 1 or negative 1 to 1. When features have different scales and we want equal contribution from all features. Standardization, rescaling data to have a mean of 0 and a standard deviation of 1. So that's the unit variance. When we want to ensure that the variance is uniform across all features. Feature extraction, transforming arbitrary data such as text or images into numerical features. And this is to reduce the dimensionality of data and make patterns more apparent to learning algorithms. And then dimensionality reduction, reducing the number of variables under consideration by obtaining a set of principal variables. And then this is to reduce the computational cost and improve the model's performance by reducing noise. Discretization, transforming continuous variables into discrete ones. And this is to handle continuous variables and make the model more interpretable. Text preprocessing, tokenization, stemming, lemmatization, etc., to convert text to a format usable for machine learning algorithms. And this is to process and structure text data before feeding it into a text analysis model. Imputation, replacing missing values with statistical values such as mean, median, mode, or a constant to handle missing data and maintain the data set integrity. And then feature engineering, creating new features or modifying existing ones to improve model performance. And this is to enhance the predictive power of the learning algorithms by creating features that capture more information. So let's see if we can answer some more questions. Um, what data preprocessing feature is used to create new features or modifying existing ones to improve model performance? So, dimensionality reduction. No, that's not okay. Okay, hold on. To create new features. Feature engineering. Engineering. Okay. Yeah. Okay. Now, utilizing count vectorizer. Machine learning models understand numbers, not text. This means the text needs to be transformed into a numerical format. Count vectorizer, a class provided by the scikit-learn library in Python, achieves this by converting text into a token word count matrix. It is used to prepare the data for the machine learning models to use and predict decisions on. So here we are using the count vectorizer function from the sklearning library. So feature extraction.txt. So we're going to import this, and then we're going to set up a variable, and then we're going to invoke the count vectorizer, and then we're going to say fit transform data frame message, and then we're going to print it. Okay. Train, test, split data set. It's important to test the model's performance on unseen data. By splitting the data, we can train our model on one subset and test its performance on another. So let's keep going. Okay, so it printed. Okay, so we have the training set and we have the test set. Here, variable x contains the data set. We will use the functions from the SK library to split the data set into training data and testing data. So, import train test split. So, the data frame classification, X train, X test, Y train, Y test. And then we're calling the train test split and we're passing in X and Y and test of zero point 0.2, the test size. Okay, the first argument to train test split is the feature matrix X, which you obtain from the count vectorizer. This matrix contains the token counts for each message in the dataset. Y. The second argument is the labels for each instance in your data set, which indicates whether a message is spam or ham. So test size is zero point 0.2. This argument specifies that 20% of the data set should be kept as a test set and the rest, 80%, should be used for training. It's a common practice to hold out a portion of the data set for testing to evaluate the performance of the model on unseen data. This is where the actual splitting of data into training and test sets happens. Okay, so it is. Okay, during the data splitting step, 20% of the data set was split for testing. What is the percentage weight age average of precision of spam detection? Okay, so we got to keep going. Okay. The function then returns four values: X train, the subset of the features to be used for training; X test, the subset of the features to be used for testing; Y train, the corresponding labels for the X train set; Y test, the corresponding labels for the X test set. So now model training. Now that we have the data set ready, the next step should will be to choose the text classification model and use it to train on the given data set. Some commonly used text classification models are explained below. So we have naive Bayes classifier, a probabilistic classifier based on the Bayes theorem with an assumption of independence between features. Is particularly suitable for high dimensional text data. Support vector machine or SVM, a robust classifier that finds the optimal hyperplane to separate different classes in the feature space. Works well with nonlinear and high dimensional data when used with kernel functions. Logistic regression, a statistical model that uses a logistic function to model a binary dependent variable, in this case, spam or ham. Decision trees, a model that uses a tree like graph of decisions and their possible consequences. It's simple to understand but can overfit if not pruned properly. Random forests, an ensemble of decision trees, typically trained with the bagging method to improve the predictive accuracy and control overfitting. And boosting machines, or GBM, an ensemble learning method, is building strong predictive models in a stage-wise fashion, known for performing random forests if tuned correctly. And then K nearest neighbors, or KNN, a non parametric method that classifies each data point based on the majority vote of its neighbors, with the data point being assigned to the class most common among its K nearest neighbors. Okay, model training using naive Bayes. Naive Bayes is a statistical method that uses the probability of certain words appearing in spam and non-spam emails to determine whether a new email is spam or not. So this is how it works. Let's say we have a bunch of emails, some labeled as spam and others as ham. The algorithm learns from these emails. It looks at the words in each email and calculates how frequently each word appears as spam or ham emails. For instance, words like free, win, offer, and lottery might appear more in spam emails. The algorithm calculates the probability of the email being spam based on the words it contains. When the model is trained with naive Bayes and gets a new email that says, for example, win a free toy now, then it thinks win often appears in spam, so this increases the chance of the email being spam. Free is often common as spam, further increasing the spam probability. Toy might be neutral, often appearing in both spam and ham. After considering all the words, it calculates the overall probability of the email being spam and ham. If the calculated probability of spam is higher than that of ham, the algorithm classifies the email as spam. Otherwise, it's classified as ham. So this is how it trains the model using Python. So we import it and we call it multinomial in B, and we're invoking that, and then we're fitting are X train and Y train. This is the training data you want the model to learn from. It's the token counts for each message in the training data set obtained from the count vectorizer. These are the correct labels, either spam or ham, for each message in the X train data set. This is where the actual training of the model happens. The fit method is used to train or fit the model on your training data. When we call the fit method, the multinomial MB model goes through the data and learns patterns. In the context of naive Bayes, it calculates the probabilities and likelihoods of each feature, word, token being associated with each class, spam or ham. These calculations are based on Bayes' theorem and the assumption of feature independence given the class label. Once the model has been trained with the fit method, it can be used to make predictions on new, unseen data. Okay, so then model evaluation. Let me keep going. Okay. Yeah, so here it is. Okay, so the weighted average is 0.98. 0.98. Yep. How many of the test emails are marked as spam? Okay. The classification report function takes in the true labels Y test and the predicted labels Y pred and returns a text report showing the main classification metrics. So the precision. This is the ratio of correctly predicted positive observations to the total predicted positives. The question it answers is, of all the samples predicted as positive, how many were actually positive? Recall, or the sensitivity. The ratio of correctly predicted positive observations to all the actual positives. It answers the question, of all the actual positive samples, how many did we predict correctly? The F1 score, the harmonic mean of the precision and recall metrics. It gives a better measure of the incorrectly classified cases than the accuracy metric, especially when there's an imbalance between classes. Support. This metric is the number of actual occurrences of the class in the specified data set. Accuracy. The ratio of correctly predicted observations to the total observations. Macro average. This average, the unweighted mean per label. Weighted average. This metric averages the support weighted mean per label. The report gives us insights into how well your model is performing for each class and overall in terms of these metrics. So, testing the label. Once satisfied with the model's performance, we can use it to classify new messages and determine if they are spam or ham. So, we provide a message. Today's offer, claim your $150 euro worth of discount vouchers. Text yes to 8502 now. So we're trying to see if it's spam or ham. Okay. Okay. What's next? McSkitty is happy that a workable spam detector model has been developed. She has provided us with some test emails and the file test email CSV and wants us to run the prepared model against these emails to test our model results. So this email is spam. Oh, okay, because I didn't pass it in. Okay, this is what happens. So, test emails.csv. Okay, let's try this one more time. Okay. Okay. So three of the messages were marked as spam. One of the emails that is detected as spam contains a secret code. What is the code? Okay. Okay. So this is okay. The secret code is I hate Best Festival. Okay. I hate. Okay. So I hope you learned something in this video. I did as well. I really haven't played with AI or machine language, so I really love the advent of cyber rooms because it lets you learn new topics that you haven't played with before. And I hope you learned something. I did, and I can't wait to see you in the next video. Have a good day. Bye.